Alright, so we're now going to take a look at the conic section of a parabola. So whenever you take a cone and slice it with a plane such that the plane is parallel to the nape of your cone, the nape being your lateral surface right here. So when this plane is parallel to the opposite surface, that generates your cross section right here, which is a parabola. Alright, so two different types of orientation. You can have vertical orientation, which means that your parabola either opens up or down, and a horizontal orientation, which means your parabola either opens to the right or to the left. And here are your two equations. Notice the difference in your equations. When you have a vertical orientation, your equation starts with y equals. So one way that you can remember this is that if it starts with y, then the y direction is vertically. Okay. If it starts with x, your x direction is horizontally. And also notice that your h and k values are right here, and then in the other orientation they are switched. Those are some of the main differences in your equations. Definition of a parabola. The set of all points that are equidistant from a fixed point, called the focus, and a fixed line, called the directrix. What it comes down to is this. Every point on a parabola, if you drew a line from the focus to that point, and from that point straight down to the directrix, those two distances would be equal to each other. And it doesn't matter where you do it. If you pick a point over here, draw that segment, those are the same length. Pick a point here, draw that segment, they're the same length. So every point on the parabola has that property. Alright, so let's take a look at your vertical orientation. Here's your equation. Now your A value is considered a vertical stretch or compression, but it also can be a reflection over your x-axis as far as your transformations are concerned. If your A value is greater than 0, meaning it's positive, the parabola is going to open up. If it's negative, the parabola will open down. That is if it is a vertical orientation, which means it starts with y equals. If your equation starts with x equals, then if your A value is positive, it will open to the right, and then if your A value is negative, it will open to the left. Okay. Alright, so our vertex is always located at HK. Keep in mind that for vertical orientation, your H is on the inside, K is on the outside. For horizontal orientation, H is on the outside and K is on the inside. So they switched. Vertex is HK for both of them. Now A is equal to 1 over 4P. And what is P? P is the distance from the vertex to the focus, which would be from here to here. That distance is P. It's also the same thing as the vertex to the directrix. From here to here is also P. Okay, so your line right here is called your directrix. Vertex, your focus, is that point right here. And the distance across your parabola going through the focus is called the latus rectum. The latus rectum has a length of 4P. Because remember, if I draw this down right here, this is the same length as this. So this would be 2p. From here to here is the same distance as here to here from what we just did on the previous page. So this would also be 2p, which means the whole segment here would be 4p. Alright, so let's take a look at some of the problems that you're going to be working. First one, find all the indicated information about this parabola and then sketch a graph. Alright, so to start out, the a value is the 1/8. The h value is the 4. The k value is 2. And then p. Well, we know that a is equal to 1 over 4p. And we also knew the value of a was 1/8. Well, that tells us that p would have to be 2. Because 4 times 2 would give us the 8 that we need for our denominator. Alright, so let's, and then the vertex is hk, so that was 4, 2. Let's go ahead and plot the information that we know. 1, 2, 3, 4, 1, 2. There is your vertex. We know it's a vertical orientation because it's y equals. And because the a value is positive, it opens up. Well, that means our parabola is going to be like this, which means also that your focus has to be inside the parabola. So from your vertex, you're going to go up to get to your focus. How far do you go up? That's the p value. So you're going to go up 2 units, and that is your focus. Now your directrix, instead of going up 2 units, you would go down 2 units. So your directrix is actually the x-axis. All right. Well, the lattice rectum, if you'll remember, that has a length of 4p. So 4 times 2 is 8. Also remember that p is a length, which means p will always be a positive number. All right, the equation for your directrix here is going to be y equals 0. And the focus has coordinates of 4, 4. All right, so actually drawing the parabola here. We know that the length of the lattice rectum is 8. So you're going to go 4 units to the right and 4 units to the left of your focus. That would be a total length of 8 for your lattice rectum. And then your parabola goes through those points. So your domain is going to be negative infinity to positive infinity and a range of 2 with a bracket because it is included to infinity. Alright, so let's take a look at the next one, example 2. Our a value is 1/4. That's the number in front of your parentheses. And a is equal to 1 over 4p. So that gives us 1/4 equals 1 over 4p. So p in this case will be 1. H is the number outside the parentheses. K is -1. Because it's x equals, this is a horizontal orientation, meaning it opens either to the left or to the right. And because the a value is positive, that means it opens to the right. So our vertex is -3, -1. So 1, 2, 3, -1. There's your vertex. Because it opens to the right, we're going to go to the right to get to your focus. Since the p value is 1, that's how far we go to get to our focus. So the focus has a coordinate of -2, -1. The directrix will be 1 unit in the other direction. So that is x equals -4. The length of the lattice rectum is 4 times p, so 4 times 1 is 4. The graph, well, since your lattice rectum is 4, you're going to go 2 units on each side of your focus. And that will be your parabola going through those points. So your domain is going to be from -3 with a bracket because that number is included, and your range is -infinity to positive infinity. Okay. All right. This time, instead of giving you an equation, we're going to go from some information about our parabola. All right. So let's start here. The focus is -2, -3. It's right here. And directrix is x equals -6. 3, 4, 5, 6. There's your directrix. There's our focus, which means your vertex has to be halfway in between those two things, which would put us at -4, -3. So that's our h and k, -4, -3. That also means that our p-value is 2. And since a is 1 over 4p, that would make it 1 over 8. All right, so the length of the lattice rectum is 4p, so that will be 8, telling us that we need to go 4 on each side of the focus. And we can draw the parabola there. So your domain is going to go from -4 to infinity. Your range is -infinity to positive infinity. And the equation, since this is a horizontal orientation, it starts out with x equals a is 1/8, and because it's opening to the right, it's positive. Y minus k means minus -3, which makes it +3 squared, plus h, which would be a -4. All right, the second problem. Again, let's just sketch out what we've got here. 1, 4. That is our vertex. Directrix is y equals 0, so that's a horizontal line, which means our focus is 4 units above. That puts your vertex halfway between your focus and your directrix. So we can get a lot of information out of this. P is 4 units. The vertex is 1, 4, so that's h and k. A is 1 over 4p, so that would be 1 over 4 times 4, or 16. Coordinates of the focus are 1, 8. Length of the lattice rectum will be 4p, which is 16. Lattice rectum 16, which means you're going to go 8 on each side of your focus. So your domain is -infinity to infinity. range is from 4 to infinity. Vertical orientation, so the equation starts out with y equals a x minus h, so it's minus 1 squared, plus k, which is 4. All right, let's take a look at going from a graph now. Your a value is going to be 3. I'm sorry, your p value is going to be 3. That is from here to here, which means a is 1 over 4 times that. Your vertex has coordinates 1, 2, 3, 4, 5, 2, which means that is your h and k values. The length of your lattice rectum is 4p, which would be 12. Your directrix, 1, 2, 3, 4, 5, is y equals 5. Your focus is 5, negative 1. That was given to us. Your domain, negative infinity to infinity. And then your range goes from bottom to top. So remember, it's going from negative infinity up to positive 2. And that is included. Your equation, it's a vertical orientation, so it starts out with y equals. Now it's opening down, which means our a value is actually going to be a negative number. So our a value is negative 1/12. And then you have x minus h, so that's minus 5 squared, plus k, which is 2. And then the last problem here. All right. P is a very small value right here. This is a crossing at a half, so P is going to be 1/2, which means A would be 1 over 4 times a half. 4 times a half is 2. So A also is a half, opening to the right, so it's positive. Your vertex is at 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Negative 4, 6 is your vertex. Length of the lattice rectum be 4p, which is 2. The directrix is x equals 1, 2, 3, 4.5. Your focus is negative 3.5, and then go up 6. Domain is from negative 4 with a bracket to infinity going to the right, and then your range is negative infinity to positive infinity. Horizontal orientation, so it starts out with x equals a, which is 1/2, y minus k, so it's minus 6 squared, plus h, which would be a minus 4. All right, that concludes our notes on your parabolas.